consider a block of ice in the form of a cube with length x. So that will imply that each of this length here is x. So that will be x, x, and x. As the cube melts, there are several changes that we will measure. One of them is the rate at which the length changes, and that can be expressed as dx over dt. The other one is the rate at which the volume changes, which could be expressed as dv over dt. And we can connect these rates of change using chain rule, using this relationship here. Now, dv over dx is the derivative of v with respect to x, and that can be found using this length here. And the question could be either, it could ask for either dx over dt or dv over dt. And if it's asking for dv over dt, the rate at which the volume changes, then you have to be given that quantity there. Or if it's asking for that, then you'll have to be given that quantity there. So let's look at that in example 1. So in example 1, we have a bicycle, and it has an inner tube, which can be considered as a joined up cylinder, as what we have here. And it has a fixed length of 200 meters. So this length here is 200 meters. And it has a radius. So let's just say the radius here is r. So the radius r increases as the inner tube is pumped up. Air is being pumped into the inner tube so that the volume of air in the tube increases at a constant rate of 30 centimeter cubed per second. So that statement there, this statement here, implies that dv over dt is 30. And that's important because remember, like I said, you need this quantity when you'll be finding what's being asked, which is the rate at which the radius of the inner tube is increasing. So what is required here is dv over dt. And we said that the relationship between these quantities is that dv over dt is equal to dv over dr multiplied by dr over dt. In this case, we have r because r implies the radius. And what we plan here is to use this relationship to be able to find what's being asked in this question. And we can see that this is given in the question. This is given. And this is what is required. Yeah, that's what's being asked in this question. Okay, so and what you're trying to calculate here is the rate at which the radius of the inner tube is increasing when r is equals to 2. So we'll figure that out later on. We'll use this quantity to calculate dv over dr. Anyway, so basically the situation here is we have a cylindrical shape, and the volume of a cylinder is pi r squared times height, but in this case you have length. So the volume of the cylinder or the tube is pi r squared multiplied by the length. The length is 200 meters. So because the length is fixed, we'll just plug in 200, so that will be pi r squared multiplied by 200. So this will be 200 pi r squared. So the derivative of v with respect to r, which is given by dv over dr, will be equal to, we differentiate that with respect to r, so that will be 400 pi r. Yeah, but remember, we are trying to find uh, dv over dr at r is equals to 2. We're actually trying to find the rate at which the radius of the inner tube is increasing when r is equals to 2. So at r is equals to 2, dv over dr will be equal to 400 pi multiplied by 2, which will be equal to 800 pi. So once you have this quantity, so well, we have dv over dt is 30, and we have dv over dr being equal to 800 pi. So the plan here is to substitute these quantities here into this relationship here. So if we do that, we'll end up with 30. So that implies that 30 will be equal to dv over dr is 800 pi. So we have 800 pi multiplied by dr over dt. So which implies that dr over dt will be equal to 30 over 800 pi. And that simplifies to 3 over 80 pi.